So, you want to make games. Awesome. Game development is actually a really diverse field. At its core, it's about bringing ideas to life, building those interactive worlds we all love playing in. As a game developer, your role can vary ***. You might be designing how the gameplay works, writing the code that makes everything happen, crafting the levels themselves, creating art and assets, or even testing the games you build and making sure they're fun. It's a really exciting combination of creativity and technical skills. Okay, let's talk about what a game developer actually does. It's not just pressing buttons all day. There are tons of different specializations within the field. You have gameplay programmers who build out everything from how you move your character to the smart AI opponents. Then there are graphics programmers who deal with all those amazing visual 3D models and stunning effects. Audio programmers handle all the sounds you hear in the game, from epic music to satisfying sound effects. Level designers craft the worlds where the game takes place, making sure they're fun and engaging. And finally, tools programmers build custom software that helps other developers do their jobs more efficiently. It's a really collaborative field with lots of different skills needed. Let's start with the basics. Game design is all about crafting an experience players really enjoy. We'll look at 4 key areas. First, core mechanics. These are the actions that players will be doing over and over again in your game. Think jumping, shooting, or driving. Next up is the game loop, which describes how your game works on a continuous cycle. Then we have rules, what's allowed in the game world, and finally, player goals, what are players trying to accomplish. Okay, let's talk about game engines. These are basically the workbenches that game developers use to build their projects. Think of them like a pre-built house. They give you all the essential tools you need without having to start from scratch. Unity is really popular because it's super user-friendly and can handle both 2D and 3D games, and it uses C# for scripting. Unreal Engine is famous for its incredible graphics and visual scripting system called Blueprints, which lets you create game logic without writing a lot of code. And finally, there's Godot. It's completely free, open source, and becoming increasingly powerful, especially for 2D games. It uses a different scripting language called GDScript. Okay, so when it comes to making video games, you have 2 main approaches, 2D and 3D. Think of 2D as your classic platformers or side-scrollers. We're talking about flat images and simpler movements. It's a really great way to start learning game development because tools are generally easier to use and it doesn't need super powerful computers. Now, 3D is all about creating games in a 3-dimensional world like Minecraft or Grand Theft Auto. This involves building models, textures, and handling complex physics. It's definitely more demanding in terms of both art and programming skills, and you'll need some serious hardware to run it smoothly. Ultimately, the choice between 2D and 3D depends on your game idea, your team's skill set, and what kind of experience you want to create for the player. Okay, let's talk about how physics works in games. It's all about making things interact believably. We'll start with collisions, those moments when objects bump into each other, like a character hitting a wall. There are different ways to detect these, from simple box checks to more complex polygon intersections. Next up is gravity. It's the force pulling everything down, and we need to constantly adjust the position of our objects based on how strong that pull is. Finally, we have rigid bodies, essentially solid objects like boxes or characters that respond realistically to forces and collisions. Game engines do most of the heavy lifting here, calculating all the physics for you. Okay, let's talk about what keeps a game running smoothly, the game loop. Basically, every game runs on this continuous cycle. It's like the heartbeat of your project. First, it takes in player input, those keyboard presses or mouse clicks. Then, it uses that input to update all the game logic, moving characters, checking for collisions, updating scores, you name it. Finally, it draws everything onto the screen. This whole process repeats over and over again, usually around 60 times a second, creating a smooth, responsive experience. Within this loop is something called the update cycle. This is where all the important logic happens, prioritizing things like character movement before less critical updates. Okay, So think of the rendering pipeline as a series of steps that turn complex 3D scenes into what you see on your screen. First, we take all the geometric information, things like shapes and positions, and transform them to fit where they need to be on the screen. Then, we convert those shapes into pixels, which are basically tiny dots of color. Finally, each pixel gets its color determined by a bunch of calculations using shaders, which is where lighting and special effects come in. It's like an assembly line for creating visuals, and understanding this process helps us make games look amazing and run smoothly. Okay, so shaders and materials are key to making games look amazing. Shaders are basically mini programs that run on your computer's graphics card, telling it **** things should appear like how light bounces off a surface. They come in different types. Vertex shaders adjust the 3D model shape, while fragment shaders determine each pixel's color. It's like having a painter and brushes, where shaders are the brush and materials are the paint. They work together to create realistic or stylized visuals. Okay, so when we're talking about lighting in games, it's *** more than just making things bright. It's really about creating a mood and guiding the player. We start with ambient light that's like the overall background glow, almost like daylight. Then, directional lighting simulates realistic sources of light like the sun or spotlights, and it's responsible for those amazing shadows. Point lights are great for things like torches, and spotlights let you really draw attention to specific areas. And don't forget about bloom and rim lighting. That subtle glow around bright objects adds a lot of depth and polish. Mastering these techniques is what makes a game * look * incredible. Okay, let's talk about bringing characters to life in games. This step focuses on character animation and rigging, essentially building the digital skeleton for your character. Rigging is like creating a virtual skeleton that controls how they move, and then we animate those bones to make them look alive and expressive. We'll be placing joints, connecting the mesh to the rig, and adding some clever constraints to ensure everything works smoothly. Okay, let's talk about sprite sheets and texture atlases that are super important for making games run smoothly. Basically, a sprite sheet is like a collage of tiny images all packed into one big image. Think of it as a single canvas holding lots of little sprites. This way, you don't have to constantly swap textures between different parts of your game, which saves the CPU from working so hard. The Texture Atlas does something similar but for larger, more detailed textures like terrain or complex character sprites. It groups related textures together into one image, minimizing the need to change textures repeatedly. Using these techniques really helps reduce draw calls. That's how many times your computer has to tell the graphics card what to display, which leads to better performance and saves memory. Okay, let's talk about game asset management. It's a really important step in the development process. Think of it as keeping everything tidy and organized so you can find what you need when you need it. The first thing is to get your folder structure and file naming conventions right. Consistency is key here. Then, always use version control like Git to track changes and work together smoothly with your team. You'll also want a good asset pipeline, something that automates the process of getting assets into your game engine. Finally, don't forget to add helpful metadata to each asset like tags and descriptions, and document how you're using them in the project. Okay, let's talk about UI design in games. It's way more involved than just slapping some buttons on the screen. A good game UI is clear, so players instantly understand what to do. Think about how you give feedback when they interact, highlighting things, showing progress bars. We also want a logical hierarchy, bigger text for important stuff, consistent styles throughout the whole interface, and different elements like health bars and inventories need careful consideration. Okay, let's talk about how players actually do things in your game. That's input handling. It's all about taking what the player is doing, whether it's pressing a key on their keyboard, moving the mouse, using a controller, or tapping on their phone screen. Keyboard controls are often pretty straightforward. You map keys to actions like move and jump. The mouse lets players aim and select things with clicks and movement. Game controllers send button presses and stick movements, which your game needs to understand. And finally, touch input is super important for mobile games. It's all about detecting those taps and gestures that make the gameplay feel really intuitive. Okay, let's talk about how games actually think asterisk. It's not like a regular program where you tell it exactly what to do step by step. Instead, games use something called event-driven programming. Basically, they react to things that happen, you pressing a button, an enemy bumping into the player, or even just the passage of time. It's a really clever way to build complex gameplay. Imagine it like this: there's an event key press, for example, and then there's a handler function that knows what to do when that event happens. So when you press space, your player jumps. This makes games feel super responsive and lets you build really intricate systems in a logical and organized way. Okay, so let's talk about how sound fits into a game. Think of audio as the fourth dimension. It can really pull players right into the world. We've got three main areas: background music, which sets the overall mood, like a dramatic score in a dark dungeon, or upbeat tunes during a race. Then there are sound effects, those little whooshes and clangs that happen when you jump, shoot, or open a door. Good SFX make everything feel much more responsive and believable. Finally, we have 3D audio, which is super important for making players feel like they're really in the game world. It's about understanding where sounds are coming from, whether it's behind you, to your left, or directly overhead. There are some awesome tools out there, like Fmod and WWise, that help you manage all of this effectively. Let's talk about particle systems. They're a secret weapon for adding incredible dynamic visuals to games without needing a ton of detailed models. Basically, they simulate loads of tiny little things like smoke, sparks, or even magical effects. Think about how explosions look in your favorite game. Often, that's thanks to clever use of particle systems. They work by defining an emitter, the place where the particles start, and then controlling their attributes like color, size, and lifespan. You can also add powerful shaders to make them really shine, with effects like heat distortion or flickering flames. Particle systems are used everywhere in games, from creating realistic weather effects to adding dramatic explosions and magic spells. Okay, let's talk about scenes and how we move between them in a game. Think of scenes as separate rooms or levels. They're the distinct parts of our game world. We organize these scenes into a hierarchy, like a family tree, making it easy to navigate and control where we are. When a scene is needed, it loads. When it's not, it unloads. This helps save on resources. And transitions? Those are how we get from one scene to another. There are lots of different ways to do that: simple fades, sliding doors, or even instant warps. The key is to think about how the player moves between these places and make those transitions feel smooth and deliberate. It really adds a lot to the overall experience. Okay, so let's dive into how AI is making games really smart. We're talking about more than just following pre-programmed instructions. First up is pathfinding, essentially figuring out the best way for an enemy to get from one place to another, like a really efficient navigation system. Then we have state machines, which are great for simple behaviors. Think of them as if this, then that scenarios for your characters. Finally, behavior trees offer a more flexible approach by breaking down complex actions into smaller, manageable components, almost like building with Legos for AI. Okay, let's talk about pathfinding in games. Imagine your character trying to navigate a complex level. They need to find the best way to get from point A to point B. That's where algorithms come in. We're going to look at two powerful tools, Dijkstra's and Asterisk. Dijkstra's is great for finding the shortest path from one starting point, always exploring nodes closer to the start first. Asterisk takes this a step further by using a heuristic, essentially an educated guess about how far away the destination actually is. This helps it make smarter decisions and usually finds the best path much faster, especially in big maps. The choice of which algorithm to use depends on what's most important for your game, like speed or guaranteed optimality. Hey everyone, let's talk about procedural content generation. It's a really cool way to build games. Basically, instead of designing every single level or texture by hand, we use algorithms to create them automatically. This can save tons of time and make your game feel much more dynamic and replayable. There are several techniques like wave function collapse for creating maps, systems that define rules for levels, and even methods for generating textures. It's a fantastic tool for building huge, complex worlds without getting overwhelmed by the sheer amount of design work. Okay, let's talk about how we save and load game data. Think of it like taking a snapshot of your game at any given moment, the player's position, inventory, level progress, all that stuff. Serialization is the key to doing this. We have a few main ways to do it. JSON, which is super popular because it's easy for humans to read and understand. XML, which is great when you need a really structured format. And then there's binary, which is like sending data in its purest form, making it incredibly efficient but also a little trickier to work with. Okay, let's talk about keeping track of the game's well. That's what we call game state. It's everything from where your character is to what you're carrying and even how much health they have. Think of it as a snapshot of the entire game at any given time. Now, persistence is all about making sure this information doesn't disappear when you close the game. We use different ways to do this: simple storage on your computer, dedicated save files, or even syncing to the cloud if you want. It's a surprisingly important part of game development because it affects player experience and how much progress they can make. And finally, let's not forget about load order, how you put everything back together after loading a saved game. Okay, let's talk about saving and loading in game development. It's a really important part of keeping players engaged and letting them enjoy their games without constantly starting over. There are basically two main ways to approach this. We can have the player manually save their progress at key moments, like after beating a level or boss, for example. Or we can set up auto-saves, where the game automatically saves periodically, which is helpful for players but can sometimes feel a little disruptive. Now, let's look at how that data actually gets stored. We often use formats like JSON, which is easy to read and very flexible, perfect for smaller games or when you're just getting started. For bigger projects, binary files are more common because they take up less space, but they can be a bit trickier to work with. And finally, there are specialized libraries that simplify the whole process and provide pre-built tools. Okay, so when we're talking about multiplayer games, it's all about getting everyone on the same page. The most popular way to do that is with a client-server model. Think of the server as the boss, and the clients are the players reporting in. There's also peer-to-peer networking where players talk directly to each other, but that can get tricky for larger games. Now, keeping everyone synchronized is a big challenge. It's like making sure everyone sees the same action happen at the same time. Client prediction and dead reckoning are two clever techniques used to do just that, basically letting the client anticipate what's happening so the experience feels smooth even if there's a little lag. Okay, so when we're talking about building a game, one of the first big decisions is how it's going to be structured, specifically its architecture. We have two main approaches: client-server and peer-to-peer. In a client-server model, there's a central powerhouse, the server that handles everything, all the rules, the assets like characters and maps, and keeps track of what's happening with all the players. Players connect to this server to get updates about the game world and to send their actions, like moving or shooting. It's great for security and easy updates, but it means you need a reliable server and can sometimes experience lag if your connection is slow. Now, peer-to-peer or P2P flips things around completely. With P2P, players connect directly with each other, acting as both the client asterisk and asterisk the server. They share information and handle processing locally. This can be cheaper in terms of running a dedicated server, especially for smaller games, and works really well on local networks. However, it comes with some challenges. Security is a bigger concern, updates are trickier to manage, and it's harder to ensure everyone has the same experience. Okay, let's talk about keeping things consistent when multiple players are in a game. That's all about multiplayer synchronization. It's actually quite tricky. We have a few main techniques. First, there's client-side prediction. Basically, each player anticipates their own actions to make the game feel responsive even with some lag. Then we have server reconciliation, where the server corrects any discrepancies between what clients think is happening and what's actually true. State synchronization, sometimes called dead reckoning, is another one, where players extrapolate based on previous data. Interest management helps us avoid sending unnecessary information across the network, saving bandwidth. And finally, lag compensation. This is a really clever trick where the server tries to predict where players asterisk will be asterisk by accounting for their latency. So, lag is basically the delay you feel in a game due to network issues. It's a really frustrating thing, especially when you're trying to compete. Now developers use some clever tricks to deal with it. Lag compensation tries to predict whether player asterisk should asterisk be based on their past movements and adjust the game accordingly. Prediction goes even further, it actually guesses where the player will be in the future. This is great for fast-moving things, but it can also cause a weird effect called rubber banding if you overdo it. It's all about finding that sweet spot between responsiveness and accuracy. Okay, let's talk about matchmaking. It's a really important part of any online game where people play together. Basically, it's how the game figures out who to put with whom to make sure things are fair and fun for everyone. There are different ways to do this. You might have skill-based matchmaking, which tries to pair players of similar ability levels, or low/glicker systems that use racing to track player performance over time. And of course, there's party matchmaking where groups of friends play together. It's not just about matching people up, it's also about things like how fast they can connect, ping, and what they actually want to play. Alright, so you've crafted a fantastic game experience for your players. They're loving the visuals and controls. But there's a whole other layer to building a truly robust game: server-side logic. This is where things get really interesting. Basically, the server handles all the stuff that needs to stick around, like player stats, inventory, or even just the state of the world itself. It's also in charge of making sure the rules of your game are actually followed and preventing anyone from cheating. And when players interact with each other, say two people battling, the server figures out what happened, collision detection, for example, and keeps track of it all. Essentially, the client is just presenting a show, but the server is making sure everything runs smoothly behind the scenes. Okay, let's talk about version control. Think of it as the single most important tool for any game developer working in a team or even solo on a large project. Game development is incredibly collaborative, and without a system to manage changes, things can quickly get messy. Version control helps with all of that. It allows multiple people to work on the same project at the same time, keeps track of every change made, lets you branch out to try new ideas safely, and most importantly, gives you the ability to roll back to an earlier version if something breaks. There are two main players here, Git and Perforce Helix. Git is incredibly popular, especially for indie developers and smaller teams, because it's free, open source, and has a huge community. Perforce, on the other hand, is often used by larger studios dealing with massive amounts of assets, so it's built for scale. Okay, let's talk about making games run smoothly. We need to make sure the graphics card isn't overwhelmed. The first thing we can do is culling, basically deciding what not to render at all. There's frustum culling, which checks if an object is completely outside of what the camera can see, and occlusion culling, which looks for objects hidden behind others. Then we have level of detail, or LOD, where we use simpler versions of models when they're far away from the player. And finally, batching. This combines similar meshes into a single draw call, reducing the number of times the graphics card has to work. Think of it like sending fewer instructions. These techniques are super important for creating great-looking games without sacrificing performance. Okay, so let's talk about memory management, a really important part of game development, especially if you're using C or C++. Basically, games are constantly creating and destroying objects, like characters, weapons, and environments. If you don't manage your memory properly, things can quickly go wrong. You have two main approaches. One where you manually allocate and free memory yourself, which gives you a lot of control, but also requires careful attention to avoid leaks or crashes. Or, you can use automatic garbage collection, like what you find in Java or C#, which handles the memory management for you, making development easier, but it can sometimes cause brief pauses in your game. Okay, let's talk about getting your game out there to everyone. Cross-platform development means building a single codebase that runs on different platforms like PC, phones, and consoles. It's that as simple as just making it work. A good engine like Unity or Unreal is almost essential to handle a lot of the platform differences for you. You'll want to think about how your game is structured so that parts that are similar across all platforms can be reused, while keeping any platform-specific bits separate. And don't forget about your art assets. They need to scale properly and look good on everything from tiny phone screens to big TV displays. Okay, so when we're talking about mobile games, it's really important to think differently than you would for a PC. The size of the screen is huge. There are tons of different devices out there, each with its own resolution and layout. And because most people play on touchscreens, you absolutely have to design your user interface with that in mind. Forget about mouse clicks, everything needs to be intuitive to tap. Then, we've got performance. Mobile devices aren't as powerful as computers, so optimizing your game for speed and battery life is key. Finally, don't forget that iOS and Android have their own unique quirks and guidelines, so you need to consider those when developing. Okay, let's dive into the exciting world of VR game development. Basically, it's about building games that you experience within a virtual reality headset. It's different from traditional game development because instead of using a keyboard and mouse, players interact with the game world using motion controllers and by moving their heads. Because you're immersed in the experience, things like performance are critical. You need really high frame rates to avoid making people feel sick. The big engines for VR are Unity and Unreal Engine, and you'll also work with SDK like the Oculus or Steam VR ones to connect your game to the headset. Okay, let's talk about bringing games into the real world. Augmented reality is all about blending digital content with what you see around you. We've got two major platforms that make this possible: ARKit for iPhones and iPads, and ARCore for Android devices. These tools use the device's cameras and sensors to understand where things are in the environment. It's like giving your game a sense of place. They rely on concepts like anchor points to keep virtual objects attached to real surfaces, and plane detection so you can put things down on tables or floors. You'll find AI used in all sorts of games, from location-based adventures like Pokémon Go, to fun filters on social media, and even interactive toys that let you place digital items in your own home. Okay, let's talk about how we can bring games to everyone. Traditionally, you needed a powerful computer or console to play the latest titles, but cloud gaming and streaming are changing that completely. With cloud gaming, the game actually runs on remote servers. Think of it like renting a super powerful gaming machine. You just watch the video output from those servers, which is streamed directly to your device. Streaming is similar, but focuses specifically on delivering that real-time video smoothly, adapting to your internet connection so you always have the best possible experience. We'll cover some key technologies like server-side rendering and adaptive bitrate streaming, essential for making this work. Let's talk about physics engines. These are the unsung heroes of many games, responsible for making everything move and interact believably. We've got a few big players. Box2D is a fantastic, speedy 2D engine perfect for platformers or anything that looks good from above. Then there's PhysX, developed by NVIDIA, which offers incredible performance and can handle some really complex things like cloth or even breaking objects in your game. And finally, we have Bullet Physics Library, which is super flexible and works well both in 2D and 3D. Choosing the right engine depends a lot on what kind of game you're building, its size, where it's running, and how much performance you need. Okay, let's dive into collision detection. It's a super important part of game development. Basically, it's how the game figures out when things are bumping into each other. There are several ways to do this, from simple bounding boxes which are fast but not super accurate, to using circles for round objects, or obboxes, which is really common in 2D games. Once we know something has collided, it's time to figure out what happens. Do we just stop the movement? Or maybe apply a little push to separate the objects? Sometimes, like in a fighting game, collisions trigger damage-reducing health points. Ultimately, how you handle those collisions depends on the specific feel and gameplay of your game. Okay, let's dive into how we can make our games look great while keeping them running smoothly. Today's topic is rendering optimization, specifically occlusion culling and light baking. Occlusion culling is like a smart way to tell the engine, hey, don't render that tree because it's completely hidden behind another one. It prevents wasted processing power on things you and your players can't even see. Then we have light baking, which basically lets us pre-calculate lighting for static objects like buildings or landscapes and store it in textures. This way, at runtime, the engine doesn't have to do all that complex lighting calculation every single frame, resulting in a big performance boost. Okay, let's dive into shader programming. It's a really exciting area of game development. Essentially, shaders are tiny programs that tell the graphics card exactly how to draw everything you see on your screen. We have a few different languages we can use. GLSL is common with OpenGL, HLSL is popular for DirectX and Unity, and then there's Shader Graph in Unity, which lets you create shaders visually without writing any code at all. It's fantastic for beginners. Shaders are broken down into stages. The vertex stage handles the basic shapes of objects, and the fragment or pixel stage decides what color each individual pixel should be. And finally there is geometry, which allows for some really cool special effects. Okay, so when we're talking about animation in games, it's not just about swapping animations. We need a smart way to control them and make sure they look really good. That's where animation controllers and blend trees come in. An animation controller is like the central command center, deciding when each animation shows up based on what's happening in the game, your character's speed, or if they're pressing a button. Then we have blend trees. They're like having multiple animations ready to go, and the controller intelligently mixes them together to create smooth transitions instead of jerky cuts. Think about a character running. You don't suddenly switch from walking to running. It's a gradual blend. It's super efficient because only the parts of the animation that are needed at any given moment are actually playing. Okay, so today we're looking at Cinemachine. It's a total game changer when it comes to camera control in Unity. Think of it as your personal director for your game. It's built around some really helpful modes like Director Mode, which gives you preset camera moves that are super easy to use. Then there's Follow Camera, perfect for making your player's perspective smooth and engaging. And if you need cameras that automatically track objects like a drone following the player or a spotlight moving with an enemy, tracked cameras are your friend. Cinemachine also lets you create virtual cameras, which are basically cameras in your scene without needing to actually create game objects for them. Basically, it takes all the complexity out of getting great camera shots. Okay, let's talk about level design. A really good game isn't just about cool graphics, it's about how you play it. The first thing to nail down is the core loop. What will players be doing over and over? Then think about their goals within each level. It's important to create a balance between challenge and flow, so players are engaged but not frustrated. Don't forget that your environment can tell a story too, using things like lighting and sound. And of course, make sure players know where they're going. Clear wayfinding is key. Okay, so as game developers, we often deal with an asterisk of assets, models, textures, sounds, you name it. Managing all that stuff can be tricky, especially when releasing to players around the world. That's where asset bundles come in. They're like mini packages of content that we can load only when needed, which dramatically reduces download sizes and speeds up loading times for the player. And then, to really get those assets to players quickly, we use content delivery networks or CDNs. These are basically networks of servers strategically placed around the globe, caching our game files closer to where players are located, minimizing latency and making sure everyone gets a smooth experience. Okay, let's talk about getting really smart with your game, specifically how analytics can help. Think of it like this. You're building a fantastic castle, but without knowing how people are exploring it, or where they're struggling, you could be wasting resources. Analytics lets us see exactly what's happening in the game, which areas players love, where they get stuck, and even how they spend their money. We can track player behavior like the routes they take, how long they play each level, and what items they pick up. And it's not just about fun. We can also see if people are dropping off, leaving the game before finishing a level or a quest. There are plenty of tools out there to help, from free options like Firebase Analytics to more powerful ones that offer really detailed insights. Okay, let's talk about how developers can actually make money from their games. We'll dive into in-app purchases, those things you see inside the game itself, and look at different ways to get paid. There are a few key types of IAP: consumables like extra lives or boosts that disappear as you use them, non-consumables like cool character skins or map packs that you buy once and keep forever, and then there's the subscription model where players pay regularly for ongoing access. But it's not just about in-app purchases. We also need to look at other ways to bring in revenue, things like ads, where you can reward players with a watch video ad for a bonus, or even selling the whole game upfront as a premium title. It's all about finding that sweet spot where you're making money without annoying your players, so always test different approaches and think carefully about how monetization fits into the overall gameplay experience. Okay, let's talk about getting ads into your game. There are two main options: Unity Ads and AdMob. Unity Ads is really easy to set up if you're already using Unity because it's built right in. It's great for casual games. AdMob, on the other hand, is Google's mobile ad network. It's a bit more complex to get started with, but often offers wider reach and potentially higher payouts. I've put together a quick table to highlight some of the key differences between them, like setup and pricing. You'll want to check out the Unity Ads dashboard and create an account and then integrate the SDK, or you can set up a Google AdSense account for AdMob and generate your ad unit ID. Okay, let's talk about taking your game global. We often think of localization as just translating the text, but it's actually a much bigger process. Internationalization is the core. It's all about designing your game from the start to be adaptable to different languages and cultures. It's like building a strong foundation that can handle variations later on. Localization then takes that foundation and customizes it specifically for a particular market, which might involve translating text, adjusting date formats, or even rethinking some of your cultural references. It's really about making sure your game feels natural and relevant to players around the world. Okay, so after all that coding and design, it's time to really put the game through its paces. Game testing and QA is a super important part of development, basically making sure everything actually works and is fun. We start with internal alpha testing, where the developers themselves play the game to catch big problems early on. Then, we move on to beta testing, which involves letting a group of players outside the team take a look. Their feedback is invaluable for spotting things you might miss. Regression testing ensures that when fixes are made, they don't accidentally break other parts of the game. And finally, functional testing focuses on each individual feature to make sure it does what it's supposed to do. QA testers use all sorts of techniques and tools like bug trackers to keep everything organized. Okay, so let's talk about automated testing. It's a huge game changer for game development. Basically, instead of manually playing through your game over and over to find bugs, you use tools to run tests automatically. This speeds things up massively, makes the process more reliable, and lets you catch problems early before they become massive headaches. We'll look at why it's so important: faster testing, fewer errors, the quicker feedback loop, plus it helps prevent new bugs from creeping in when you make changes to your code. There are different kinds of tests too. Unit tests, which focus on individual pieces, integration tests that check how everything fits together, and system tests that simulate the whole player experience. It's all about making sure your game is polished and bug-free. Okay, let's talk about bug tracking. It's a really important part of game development. Basically, it's all about keeping track of those pesky bugs that pop up during the process. Why is this so vital? Well, it helps us catch problems early on, which leads to a much better quality game. It also streamlines our workflow and ensures everyone on the team knows exactly what needs fixing. There are tons of great tools out there like Jira and Trello. They help organize everything. And crucially, when documenting a bug, be super detailed. Write down exactly how you can make it happen, what should happen versus what actually happens, and how serious that bug is. Okay, let's talk about patching and updates, a really important part of game development. Think of it like giving your game regular checkups and upgrades. We have different kinds of patches. Hotfixes are for those super urgent problems that need fixing right away, usually with minimal testing. Then we have minor updates, which include smaller bug fixes and tweaks, and finally major updates, which bring in substantial new content or features. These require a lot more testing and feedback from players. There's different strategies you can use too: rolling patches, where you apply changes bit by bit over time, full updates that bundle everything together, or even blue-green deployments to minimize downtime. Remember, clear communication with your community and solid testing are essential for making sure your patches go smoothly. Okay, let's talk about live ops. This is a super important part of game development after launch. Basically, it's all about keeping your players engaged and coming back for more. Think regular content updates, exciting events, and making sure you're actually listening to what they have to say. It's not just fixing bugs, it's actively shaping the player experience. We'll look at some of the core components like content planning, events, community interaction, and how data helps you make smart decisions about what to do next. And don't forget the tools. Analytics platforms, CMS systems, and communication channels are all key for successful live ops strategy. Okay, so as game developers, we often think about the fun parts: designing levels, creating characters, crafting engaging gameplay. But behind all that, there's huge amount of server-side work needed to keep things running smoothly and handle player data. That's where cloud backends come in. We're talking about services like PlayFab, Photon, and Firebase. These are essentially hosted servers that take care of all the heavy lifting. PlayFab is a really comprehensive solution, offering everything from managing players and leaderboards to handling game economies. Photon specializes specifically in real-time multiplayer, making it fantastic for games where players need to connect and interact simultaneously. And then there's Firebase, which is a great option if you're building something smaller or medium-sized and just need reliable ways to keep your game data synchronized and handle user logins. Okay, let's talk about how leaderboards and achievements can really make a game shine. There are lots of different ways to build these systems. You can have a global leaderboard showing the absolute best players across the whole game, or you might break it down by region so people compete against others nearby. You could also focus on friend-based competition, which is awesome for social gamers. And don't forget specific challenge leaderboards that reward players for doing certain things in the game. Now, achievements are a slightly different beast. They're smaller goals that keep players motivated and guide them through the content. You can have big milestones like reach level 10, or more focused challenges like defeat a boss with sword damage. And sometimes it's great to hide some secret achievements to encourage exploration. When building these, think about how you'll handle lots of players and make sure your rewards feel good. Visibility is key. Players need to be able to easily see their progress. Okay, let's talk about designing a great game economy. It's not just about slapping in some shops and hoping people buy things. You need to think about how players progress through the game, what they need to keep progressing, and create systems that naturally encourage them to want more and spend a little bit of time and money doing it. We're talking about things like leveling up gear, building skills, gathering resources, and even just interacting with other players. It's all about creating a loop that keeps people engaged and coming back for more. Okay, let's talk about the story behind your game. It's absolutely crucial. A great narrative doesn't just tell you what's happening, it draws you into the world. We want to show players things through gameplay and environment, not just deliver a wall of text. Developing interesting characters with goals and flaws is key. Think about how their decisions shape the story. And don't forget branching narratives that give players choices that actually matter. Games like The Witcher 3 are fantastic examples of how to blend amazing storytelling with exciting gameplay. Okay, let's talk about bringing the voices of your players together in a game. Voice chat is a really important part of modern multiplayer experiences. We'll cover how developers get this working. First, you need reliable communication. WebSockets are popular for that, creating a constant connection. Often, UDP packets are used for audio because they are quick and don't have as much overhead as other protocols. And to make things easier, VoIP libraries like WebRTC can handle all the technical stuff behind the scenes. Essentially, you set up your server to manage connections, then add a VoIP library to your game client to connect to it. The client captures audio from the player's microphone, encodes it, and sends it over the network. The server receives these packets, routes them to the correct players, and decodes them again for playback so everyone can hear each other. A good quality codec like Opus will make a big difference in terms of both sound and bandwidth. Okay, let's talk about dynamic audio mixing. It's way more than just turning up the volume. It's all about making your game feel alive through sound. We're looking at techniques like automating parameters, layering different audio elements together to build a really rich soundscape, and even using EQ to change how sounds are perceived based on what's happening in the game. Think of footsteps getting louder as you get closer to an enemy, or bass boosting during a high-speed chase. Collaboration with your sound designers is key here too, ensuring everything plays well together dynamically. Okay, so let's talk about building a game that doesn't fall apart when you try to add new features. We're going to look at two key techniques: dependency injection and modular architecture. Dependency injection is essentially giving your code what it needs instead of letting it figure out how to get those things itself. Think of it like handing someone ingredients for a recipe rather than expecting them to hunt them down. And modular architecture? Well, that's about breaking your game into smaller, independent pieces, each with its own job, making sure they all work well together and are easy to update or replace without messing up the whole thing. Okay, let's talk about unit testing in game development. Unit tests are all about checking the individual building blocks of your code. Think functions and classes to make sure they work correctly on their own. It's like making sure each Lego brick fits perfectly before you start constructing a huge castle. Why is this important? Well, finding bugs early saves ton of time and money later on. Unit tests also help keep your game code easy to understand and change as it grows. Some common techniques include mocking external systems so they don't throw off the test, using TDD to write tests before you code, and especially focusing on boundary testing, that is, testing what happens when you give your code inputs at the very edges of those limits. Okay, so let's talk about keeping our game safe. When we're building a game, especially one with online play, security is absolutely critical. We need to protect players from cheating and make sure their data is secure. There are two main areas here: anti-cheat measures and secure networking. Anti-cheat systems work by making sure everything happening in the game, like movement or shooting, is checked on the server, not just what the player sees on their screen. They also look for suspicious behavior and use signatures to identify known cheat code. Now, for secure networking, we need to protect how players connect and communicate with each other. This means encrypting all data so it can't be intercepted, verifying who players are, and preventing any tampering that could let cheaters gain an unfair advantage or disrupt the game. Okay, let's talk about diving into games, specifically how we can take a closer look at how they work. We're going to cover reverse engineering and modding. Reverse engineering is essentially figuring out how a game's compiled code works by breaking it down piece by piece. You use tools like disassemblers and debuggers to understand the underlying mechanics. It's like detective work for games. Then, once you know how things are built, modding lets you change those parts, adding new content, tweaking existing features, or even creating entirely new gameplay experiences. We'll need some tools like disassemblers, debuggers, and text editors to get started. Okay, let's talk about how we make sure our mobile games run smoothly. When you're developing for phones and tablets, performance is absolutely key. No one wants a laggy or crashing game. We use specialized tools called profilers to understand exactly what's happening under the hood. There are several great options like Android Studio Profiler for Android development and Xcode Instruments for iOS. Unity also has its own built-in profiler which can be super helpful. We're looking at things like frame rate, which ideally should be 60 frames per second, CPU usage, you don't want to constantly spiking how much memory the game is using, and even battery drain. Profiling involves techniques like analyzing frame times to see where each part of the process takes up most of the time. We also need to find any memory leaks that could cause problems later on, and pinpoint exactly which parts of our code are hogging the CPU. Okay, let's talk about haptic feedback, adding a really cool tactile element to your games. It's about creating that feel of touch through controllers or other devices. Why bother? Well, it massively boosts immersion and can give players crucial information without them even looking at the screen, like when they get hit or are near something important. There are different ways to do this: basic controller vibration for big events, short impulse feedback for impacts, and even more advanced localized haptics where you can feel exactly where you're touching things. Keep in mind though, that the specific hardware you use will greatly affect what kinds of haptic effects you can actually implement. Okay, let's talk about two super important things for any game dev: game jams and rapid prototyping. Game jams are like intense creative sprints where you have a limited time, usually 24 to 72 hours, to build a complete game around a specific theme. They're often held as part of a community, so it's great for collaboration. Now, rapid prototyping is all about getting your ideas off the ground fast. The goal isn't to create a polished masterpiece, it's just to test if your core mechanics are fun and engaging. You focus on building the basic gameplay loop first, using simple tools that let you get something playable really quick like GameMaker or even Unity with some pre-built templates. And most importantly, you iterate. Build a little bit, playtest it, get feedback, and then improve based on what you learn. Okay, let's talk about branching in game development. It's a really important part of how we manage our code and keep things organized. Think of it like creating separate workspaces where you can experiment without messing up the main version of your game. We have a few popular approaches. Git Flow is a structured method with different branches for everything. GitHub Flow is more streamlined, focusing on continuous integration, and then trunk-based development involves everyone working directly to the main branch, but that requires really tight testing processes. The most important thing is to branch frequently, keep those branches short-lived, and use clear names so you know exactly what's going on. Okay, let's talk about how automation can seriously level up your game development process. Think of the asset pipeline as a conveyor belt, and right now, it might be overflowing with manual work. Automating this pipeline means scripts handle things like bringing in different file types, automatically baking lighting for better visuals, optimizing textures to keep performance high, and even packaging everything perfectly for each platform you're targeting. It's all about making the process smoother, faster, and less error-prone, freeing up your team to focus on the creative stuff. Okay, let's talk about shaders. Shaders are essentially the instructions that tell your graphics card how to draw everything you see on screen. Now, sometimes these instructions can get really complex and slow things down significantly, turning into a major performance bottleneck. That's where optimization comes in. We'll cover some key tools like Visual Studio's Graphics Debugger and RenderDoc, which are fantastic for understanding exactly what's happening during rendering. Then, we'll dive into some common strategies to make your shaders leaner and faster. Things like reducing texture complexity, simplifying calculations within the shader code itself, and even using techniques like early Z-culling to avoid unnecessary work. Okay, so let's talk about taking your character animations to the next level. We're moving beyond just keyframing and exploring two really cool techniques: inverse kinematics and procedural animation. Inverse kinematics is like giving a limit goal. Say you want your hand to be in a specific position and the system figures out how all the joints need to move to get there naturally. It's incredibly helpful for things like hands and feet, where direct control gets messy. Then we have procedural animation, which is about creating motion automatically using rules and algorithms. Think of it like programming a dance. You set up the steps, and the character performs them. They're quite different, but both can dramatically improve the realism and variety in your games. Okay, let's talk about how we control our game character's AI. We often encounter two main approaches: finite state machines and behavior trees. FSM are like a simple flowchart. Your character can only be in one state at a time, switching between them based on specific conditions. They're great for basic behaviors, but get complicated quickly when you need to handle lots of different scenarios. Behavior trees, on the other hand, offer much more flexibility. Think of it as building AI from smaller, reusable pieces arranged in a tree-like structure. This makes it easier to add new behaviors, modify existing ones, and manage complex decision-making without rewriting huge chunks of code. Okay, let's talk about nav meshes. They're super important for making your AI agents actually move in a game world. Think of them like a digital roadmap for your bots. Basically, a nav mesh is a graph that represents all the walkable areas of your level. It's created by taking your 3D environment and figuring out what parts are safe to walk on, no cliffs or walls. The engine then builds this network of nodes and paths. Your AI agents use pathfinding algorithms like Asterisk to find the best route across that mesh so they can move around realistically and intelligently. Remember to update the nav mesh if things change in your level. It's key for responsiveness. Okay, let's dive into cloud saves and how we deal with potential problems. Cloud saves are fantastic for players who want to pick up where they left off on different devices. But it's not always a smooth process. You'll often run into version mismatches between platforms. PC uses one thing, mobile might use something slightly different. Network hiccups can also interrupt the syncing, and each platform has its own unique rules about how saves are handled. The good news is there's a bunch of strategies we can use to overcome these challenges, like using a central backend server that acts as a hub for all data, or writing specific code for each platform. Don't give up on those failed syncs, build in some retry logic, and always check the integrity of your saved data. Okay, so let's dive into tracking what players are really doing in your game. A good analytics dashboard isn't just a giant spreadsheet of numbers, it's about turning those numbers into understanding. We want to focus on key metrics like retention, how many people keep coming back. Session length tells us how engaged they are, and conversion rates show if they are actually achieving your goals, like buying in-game items or finishing levels. Finally, we need to watch our churn rate. Figuring out why players leave is crucial. There are a bunch of tools you can use, from Google Analytics to specialized game analytics platforms. Don't forget that the most important thing isn't just collecting data, it's using it to make smart decisions about your game. Okay, so let's talk about finding the right players for your game. It's super important to understand what kind of games they already enjoy. Think market trends and see what competitors are doing well and not so well. We need to look at things like age ranges, where they live, and even what they are interested in outside of gaming. Then we can break down the audience into smaller groups based on their habits. How often do they play? What platforms do they prefer? Knowing all this helps you make smart decisions about your game's design, marketing, and everything else. Okay, so let's dive into how to keep those players coming back and spread the word about your game. First, we need to get the word out. Think social media campaigns, influencers, and even collaborations with other games. Really focus on tailoring your message for each platform. Then, it's all about keeping them engaged. Inside your game. Consistent updates, exciting events, and maybe even strategic push notifications if you're a mobile game can make a huge difference. And don't forget to personalize the experience. Recommend content based on what players are already enjoying. Okay, let's talk about how players get better in games. A really important part of that is player progression, the feeling of constantly getting stronger and unlocking new things. We use a system based on XP, or experience points, which players earn for doing stuff like beating enemies or completing challenges. When they've earned enough XP, they level up. Leveling up doesn't just give them more power, it also unlocks cool new abilities and items. And those items? Those can be anything from awesome character skins to brand new areas of the game world. Basically, anything that keeps players excited to keep playing and exploring. Okay, let's talk about loot boxes and reward systems. These are really important for keeping players hooked in games, but they need to be designed carefully. The key is offering a good variety of items, with some rare and exciting drops. It's also super important to be upfront about how likely people are to get certain rewards. Think about creating a tiered system where players unlock better prizes as they play and progress, And don't forget to make sure the rewards actually mean something in the game. Okay, let's talk about getting controller support into your game. It's a really important step for making sure everyone can play. First off, you need to think about where you're releasing the game. Each platform has its own way of dealing with controllers. Then, you'll want a good mapping system so players can tweak things to their liking. Don't forget about dead zones and smoothing. These help make controls feel more responsive and less frustrating, especially on touch screens. And finally, testing is super important. Get lots of feedback from different users with different controllers to really dial in the experience. Okay, so getting your game onto a console or mobile store isn't just about building it. There's a whole certification process involved. For consoles like PlayStation and Xbox, you start with an application detailing everything about your game. Then comes a legal agreement outlining royalties and platform policies. The manufacturer checks the technical aspects to make sure it runs smoothly and securely. Finally, they review the content itself for age appropriateness and legal concerns. Now, mobile stores iOS and Android have their own steps. First, you need a developer account. You'll fill out metadata like the app's name and description and set a price if you want to charge. A crucial part is having a clear privacy policy that meets platform requirements. Then Apple and Google review your app based on their guidelines, things like functionality, user experience, and code quality. This can take some time, but once approved, you can release it for players to download. So, let's get your game's highlights out there. This slide covers how to record your gameplay and stream it live or as a recording to platforms like Twitch. You'll want to use tools like Unity or Unreal Engine's built-in recorder or a free program called OBS Studio, which gives you lots of control over the stream. And remember, streaming needs a solid internet connection. Make sure you have enough upload speed. Okay, let's talk about bringing in some extra superpowers to your game, specifically through third-party SDK. These are like pre-built toolkits that can add tons of functionality, from tracking how players are doing to letting them connect with friends or even monetizing the game. There are lots of different kinds out there: analytics to see what's popular, advertising to bring in some revenue, and social features so players can share their achievements. The key is choosing the right ones for your * game. Then you'll need to grab your API keys, which are like passwords for the SDK, and add code to initialize it. After that, you just start calling methods, basically using the SDK tools to get things working. Always test carefully and monitor how everything is performing after you launch. Okay, let's talk about how games handle multiplayer sessions. We're moving beyond simple client-server models to look at more sophisticated setups. First up are dedicated servers. These are like the main command center for a game. Players connect directly to them, which means they get a really smooth and consistent experience, but it comes with a higher cost of running those powerful machines. Then we have relay servers. Think of them as helpers, forwarding player requests to the main server. Relays can be cheaper and easier to manage, but there's a potential for a little bit more lag because of an extra hop. It's all about finding the right balance for your game. Okay, let's talk about scheduling events within your game. It's way more than just giving out quests. We're talking about things like dynamic weather that triggers special events, limited time sales or promotions, even letting players create their own mini-events. The core of it involves defining what the event is, how you schedule it to happen, often based on player actions or timers, and then making sure players know about it. You want to keep things interesting without overwhelming them, so finding that balance is key. Okay, let's talk about lighting. It's what truly brings a game to life. Dynamic lighting means lights that change over time, like a flickering campfire or a moving spotlight. But the really cool part is real-time global illumination. Think of it as simulating how light bounces around a scene. Instead of just seeing direct light from a source, you see the indirect light too, creating those subtle color shifts and realistic shadows. We'll look at some techniques like ray tracing, which gives super accurate results but can be demanding, and screen space global illumination, which is faster and more efficient. And then there's baked lighting, pre-calculated during development, offering great performance but less flexibility. Okay, let's talk about making games feel asterisk at asterisk. That means focusing on their UI and UX. Unlike websites or apps, game interfaces need to be incredibly responsive. Think about when you're playing a game. Do you ever just stare at the screen waiting for something to happen? It's frustrating. So, we want immediate feedback, like when your character takes damage, you see a clear visual. We also need to make sure everything is easy to find and understand. It's about guiding players without overwhelming them. And crucially, give players control. Let them feel like they are actively shaping the game world. Hey everyone! Let's talk about making games accessible to everyone. It's really important that our games can be enjoyed by players with all sorts of different needs. We can do this through things like customizable controls, so players can map the buttons exactly how they want them. Subtitles and captions are also super helpful, especially for audio cues or dialogue. And of course, colorblind modes help players distinguish colors more easily if they have a vision deficiency. Text-to-speech is great too, reading on-screen text aloud. Don't forget adaptable difficulty levels and tutorials to give everyone a chance to succeed. Okay, let's talk about game localization QA. Think of it as making sure the game really makes sense to players around the world. It's not just about swapping words, it's a deep dive into ensuring that the translated version is accurate, culturally appropriate, and doesn't break the game. We're looking at everything from text accuracy and consistency to whether the changes actually impact how fun the game is to play. The QA process involves reviewing the translations, testing the gameplay, auditing for errors, and then reporting those issues back to the localization team so they can be fixed. Ultimately, great localization builds player trust and opens your game up to a much wider audience. Okay, so when we're talking about multiplayer games, keeping things fair and fun is a big deal. There are actually 3 key layers to content moderation. Think of it like a defense system. First, you've got client-side tools that let players report problems right in the game itself. Then servers step in with automated systems and real-time monitoring for anything that might be breaking the rules. Finally, there's always a team of human moderators who can look into more complicated situations and make final decisions. We use things like keyword filters to block bad words automatically, analyze player behavior to spot suspicious activity, and even use AI to help us stay on top of it all. Okay, let's talk about the legal side of game development. It's surprisingly important. First off, everything in your game is protected by copyright, so make sure you own those rights or have licenses for anything you're using. Then there are game engine licenses like Unity and Unreal Engine that you need to understand. They come with specific rules about how you can use them. Don't forget about assets, fonts, music, 3D models. All of these often require separate licensing agreements. And if your game has an online component, you'll need a terms of service agreement and a clear privacy policy to protect both you and your players. Okay, so you've finally launched your game, awesome. But the real work doesn't stop there. Post-launch support and community management are absolutely vital for long-term success. You need to be actively fixing bugs reported by players, rolling out patches as quickly as possible. Transparency is super important here. Let them know what you're doing and why. Building a strong community around your game is also essential. Think Discord servers, forums, even Reddit. Create places where players can connect with each other and with you. Make sure to listen to their feedback. Use surveys or in-game tools to collect thoughts on the game. And don't be afraid to add new content down the line. Updates keep people interested. Finally, provide good customer support through channels like email and FAQ. A happy community is a loyal one. Okay, so after you've got the basics of game development down, it's time to look at some powerful tools. A lot of amazing games are built using open source options. Unity's Personal Edition is a really popular choice because it's super versatile. Godot.engine is another fantastic one. It's known for being really easy to pick up and use, especially if you're new to game development. Unreal Engine has a free tier that lets you experiment with its incredible graphics capabilities, and Monogame/XNA are great if you prefer CHash. And finally, LibGDX is awesome for building games specifically for mobile platforms. Okay, let's talk about procedural audio. It's all about making sounds on the fly instead of relying on pre-recorded samples. Think of it like this: we define some key characteristics for our sound, then use algorithms to generate the actual audio data in real time. This means less space needed for your game files, and a much more dynamic and responsive soundscape. We control things like pitch and volume with parameters, and then use techniques like noise synthesis or FM synthesis to translate those values into sound waves. It's a really cool way to add depth and immersion to your games. Okay, let's talk about making your game audio really come alive. We're diving into dynamic music systems, essentially music that changes based on what's happening in the game. Think of it like this: instead of just having a single track playing in the background, you can trigger different musical layers as enemies appear, or speed up the tempo when the player is racing through a level. It's all about making those audio cues really match the action and add to the overall atmosphere. Key components include identifying what triggers changes like an enemy appearing, using multiple tracks that can be blended together, adjusting things like volume and instrumentation based on game conditions, and for more advanced developers, even generating music in real time. Thank you for watching.